Hello everyone. Today we will start reviewing Unit 9, 9.1, the idea of density. Firstly, we should know what do you mean by density or the definition of density. Density is the amount of matter in a given volume. Amount of matter in a given volume. Density, it depends on two factors. It depends on mass and volume. So density, it's what? Density, it's the amount of mass in a given volume. Okay. Questions. What the mass of an object tells us how much matter is made of. What is the unit of mass? When you will have calculations, okay, for example, if you will have a question that says how much is the mass, okay, or find the mass, at the end you should write a unit. The mass will be measured with a unit which is kilogram. So mass, it's the amount of matter in an object, okay. We measure it with kilogram. Now, this question B, which has more mass, 1 kilogram of water or 1 kilogram of air? If you will focus on the question, here you have 1 kilogram of water and 1 kilogram of air. Here, okay, we don't care about the substance. What is it? Is it solid, liquid, gas, any kind of matter, okay? The mass here, it's equal. Why? Because they are saying 1 kilogram of water, 1 kilogram of air. So, which has more mass? Both of them, they have the same mass. Volume. A definition of volume, we will say how much space an object it takes. For example, if we will have 1 kilogram of iron and 1 kilogram of feather. So, what's the difference between them? If you will compare their mass, you will see their mass, it's equal. Both of them, they are 1 kilogram. Okay, each one of them is 1 kilogram. But they differ by what? They differ by the space, the space that they take. Feather, it takes more space. Okay, so now the volume, it differ. Both of them, they have the same mass, but they differ by their volume. Okay, feathers will take more space. Now, as you can see, substances now, they are differing from each other by their mass and their volume. Comparing materials. How we can compare between materials? Take a look on these substances. We have ice, water, brick, aluminum, and gold. If you will look at the volume of them, all of them now, they have the same volume, okay? But look at the mass, 0.92 grams, 1 gram, 2.3 grams, 2.7 grams, 19.3 grams. Okay, the mass of 1 cubic centimeter of a material tells us the density. Okay, now if we want to compare these substances, we will compare them by their density. Okay, now what we will say, again, definition for density, it's the amount of mass in a given volume. Okay, now the amount of this mass in this volume, it will gives us the density of ice. The amount of this mass in this volume, it will gives us the density of water, and the same thing for the others. Okay, now here we can compare among these materials by their density. Okay, we will say, for example, this one it has greater density. This one, it has greater density, for example, than ice. Okay, now questions. Look at the picture of different materials on the previous page. What is the density of gold? Now, gold here, as you can see, they said how much it's the density of it. Now, density. How to find density? Density equal to mass over volume. Okay. The density of gold here, it will be what? Mass. How much is the mass? 19.3. Okay, 19.3 grams over volume. How much is the volume? It's 1 cubic centimeter. Okay, now the density will be 19.3 grams over cubic centimeter. So in this way we can find the density of any material. Now this is the density of gold, 19.3. Okay, B, which is denser, water or ice? Okay, which one is denser, water or ice? If you will solve them, you will see now the density of water, as it's shown here. It's 1 gram per cubic centimeter, and this one for ice, it's 0.92 grams per cubic centimeter. If you compare these two numbers, which number is larger? This one. So you will say water, it has the water, it's denser than ice. Explaining density. Again, to explain the density, just memorize the definition of density, which says it's the amount of mass in a given volume. It means as much as, if we will write density equal to mass over volume. Okay, now if we want to explain the density now, as we said, mass over volume. If we want to compare objects, we will depend on what? On their mass and their volume. Now, when the density will be more and when it will be less. As much as the mass increase, the density, it will increase. As much as the volume increase, the density will decrease. Okay, so density and mass increase, density it will increase. But volume with density, they are opposite each other. If the volume will increase, the density it will decrease. Measuring density. Measuring density, you need to memorize this formula. Any question about density, you can solve it by using this formula. Density equal to mass over volume. Example, the diagram shows this diagram shows a block of cast of iron. Its volume it's 30 cubic centimeter, and its mass is 210 grams. Find the density. Well, the first step, you write the formula, and don't forget, as I mentioned in the class, always when you will have math questions, the first step, it's a must. You must write the formula. After writing the formula, you will replace the words with numbers. Here, mass, how much it's mass? It's already given here. It's 210 grams. Over volume, it's 30. So 210 over 30, you will have 7. But don't forget to write the unit of density. The unit of density, it's gram slash or over cubic centimeter. Measuring mass. How we can measure the mass of any object. As you can see here, to measure the mass of any object, you need to use this balance. Okay, a balance. We use balance to what? To measure mass. Measuring volume. To measure the volume of object, we will have two ways to measure the volume of object. It depends on the object. It depends on the shape of object. If an object has a regular shape, what do you mean by object that has regular shape? It means, look at this shape. This is a regular shape. It has a regular shape. Why? Because it has length, width, and height. Okay, this one it has length. This is the length, this is the width, and this is the height. So by using a ruler, we can find the length, width, and height. So how we will find the volume of this object? By using this formula. Volume equal to length times width times height. But sometimes you'll have an object that has irregular shape. What's that mean? It means this shape, it doesn't have length, width, and height. We don't know which one it's width, which one it's height, which one it's length. So in this case, what we will do, we will use measuring cylinder. So measure the volume of a liquid by pouring the liquid into a measuring cylinder. Read the volume from the scale. What we will do here, for example, let's say here, now the reading or the amount of water here is about 45 cubic centimeter. Okay, if we have an object that it has irregular shape, if we will take this object, if we want to find the volume of it, we will take this object, we will put it in the water. So when you will put it in the water, the level of water will change. It will increase. Okay. For example, now before putting the object here, it was 45. But let's say when you put on an object, it will be 70. Now, how you will find the volume of it? You will write 70 minus 45, and you will the result, this is the volume of the irregular shape. Density calculations. Again, to calculate the density, the first step is to write the formula. Second step, replace the words with letters. Third step, don't forget to write the unit. A unit of density, it's what? It's gram slash or over cubic centimeter. Now, a rectangular block of a steel measures 4 centimeter times 2 centimeter times 1.5 centimeter. Its mass is 93.6 grams. Calculate the density of steel. Now, how to solve it? First step, what we will do? Density equals to mass over volume. Okay. Second step, mass. How much is mass? As it's given, 93.6 grams over volume. How much is the volume? Here, as you can see, these three numbers, the 4 centimeter, it represents the length, times 2, width, times 1.5, it's the height. So if you will multiply times 4, 2 times 1.5, the answer will be 12. 12 what? 12 cubic centimeter. Now, if you will divide 93.6 by 12, you will get answer 7.8. 7.8 what? Gram slash cubic centimeter. So in this way, you can find the density of any object. Then, calculating mass. How to calculate a mass of an object? Also here, you will depend on the same formula. Okay? Here, as you can see here, the formula, it says mass equal to density times volume. We got this formula from where? From here, from this formula. It's the same formula. Now, because they are asking you to find the mass, so in the question you will have the density of object and its volume, as it's shown in this example. Just writing the formula, replace the words with the numbers and do the calculations, and at the end, don't forget to write the unit. Calculating volume. To calculate volume, okay, again, another formula. We derived this formula from the original one, which is density equal to mass over volume. Then, for volume, as we explained before, we have two ways to find the volume, okay? It depends on the shape of the object, if it's regular or irregular. Now, the summary: density, mass, and volume are connected by these three equations. Okay, you need to memorize these three equations. 9.4, pressure. Definition of pressure, or explanation for pressure: it's the amount of force exerted on a specific area or on a particular area. For example, now the pressure of this nail on this board, it's where? It's what? It's the amount of force here, okay, exerted on specific area. Now, here we have two pressures. For example, here, when the hammer is hitting the top of the nail, so force by hammer applied on area, this area, okay? Then we will have another pressure here, which is force of this tip of nail on the board. So, the idea of pressure, or the pressure, it depends on what? Here, when I explained about pressure, I mentioned force and area. So the pressure here, it will depend on two factors. It will depend on the amount of force and also the area. So the idea of pressure, if a force is concentrated on small area, we say that the force is creating a high pressure. Again, if the force is concentrated on small area, the pressure will be higher. Now, if you will look at this example, okay, these two boys, which one is acting, which one is applying more pressure on the bed? Okay, if you will focus here, the bed here is going down more than this one. The reason behind this, it's what? Here, the force is being exerted on smaller area, which is just the feet of this boy. But here the area, it's what? It's the area of the whole body. So now if you have a question, if two boys, one is laying on bed and the other one is standing on the bed, which one is exerting more pressure? Okay, if for example, let's say they have the same force, okay, but which one will exert more pressure? Of course, the one that he is standing. Why? You will say because the amount of force it's exerting on a small area, okay, as much as the area will be smaller, the pressure will be more. Another example, another explanation for it, it's like why the tip or the end of this nail, it's sharp. Okay, why they make it sharp? Because when they will make it sharp, that's mean the area of it will be smaller. When the area will be smaller, that's mean the pressure will be more, so the nail, it can goes easily through the board or through any object. Pressure calculations. Pressure is the amount of force over area. Okay, this is the formula. Unit of it, okay, it's Newton over meter square. Newton, it's what? It comes a unit for force. Square meter, it's what? It's the area. Because for example, this rectangle, if someone will ask you find the area of rectangle, what you will do, you will multiply the length by width. Okay, so if this is by meter and this, let's say here it's an example, let's say this is 2 meters, the length it's 2 meters and the width it's 2 meters. Now 2 times 2, it will be 4 square meters. Unit of pressure. For pressure, we have two types of units. Either it's Newton or N/square meter, or you can write Pascal, PA, okay, as it's shown in this example. Okay, here we have this example. A hammer hits a nail with a force of 200 Newton. So here is the force. The point of the nail has an area of 0.5 square millimeter. Okay, touching a piece of wood. Calculate the pressure. Okay, pressure here, force. First, as we said, first step you write the formula. Force, pressure, it's force over area equal to the force. How much it is? 200. Then how much is the area? 0.5. Okay, so 200 over 0.5, you will get 400 Newton. It comes from the force slash and square millimeter, it comes from the area of the nail. Calculating force. Calculating force, also we have this specific formula. We derived or we got this formula from the main formula of pressure, the one that it says pressure equal to force over area. Just we will do some changes to it. okay, then we will get force equal to pressure times area. Okay, now which unit we will use to measure the force? Always force is measured with Newton. Okay, this is the unit for measuring force. Pressure in gases and liquids. Pressure, it's what? It's the amount of force on an area, on a specific area. Now, pressure in liquids and gases. First, we will start with liquids. This person, this diver, he is swimming, he is diving. Okay, look at these numbers. It shows the depth. Here it's 0, 10, 20, 30, 40, 50. Okay, so that's mean if we will move from top to down, okay, the depth it's increasing. And look at the numbers here. The numbers, it shows the pressure. It says when he is here, the pressure is 100,000 Pascal. When he is here up in 10 meters, if the depth is 10 meter, it will be 200,000 Pascal. And as you can see, as much as he's going down, the pressure, it's what? It's increasing. Okay, so focus on this. Pressure increases with depth in water. Okay, the deeper you go, the more pressure you will have. Now, explanation for this. Why? Because the weight of water pressing on the diver increases with depth. What's that mean? As much as this diver will go deeper, that's mean more water, more weight of water will be on his body. More weight, it means more force. More force, it means more pressure. So, a question here, it will say, at which point the pressure is more. For example, at 50 meters, 30 meters, 10 meters. At which point, at which depth you think the pressure will be more? The answer, of course, here, 50. Explanation for this, you will say because the weight of water is pressing on the diver increases with depth. If you look at this bottle, you will see this bottle, it has these 3 holes, 1, 2, 3. There is water in it. As you can see, here the water, it's going further from the bottle. Here it's less, and here less. Now, the explanation for this, it's what? Here it's going further. Why? Because the pressure here, it's more. Why it's more? Because it's deeper. The deeper, as much as you go deeper, the pressure will be higher. This was everything about pressure in liquids. Now, pressure in gases. Example, pressure of the atmosphere. All of us, we know that Earth is surrounded with a layer of gases. These gases, it makes pressure. Okay. For example, let's say this, it's a mountain. Okay. If you are at these different positions, A, B, C, mention at which position the pressure, the atmospheric pressure, or the pressure that it's caused by the air particles, it's higher. Here, here, or here. The answer will be here. The pressure here will be more. Why? Because you will say more air particles are on the person. Okay, the higher you go, the less air particles will be on you. When the number of air particles will be less, that means the atmospheric pressure will be less. Particles and pressure. What do you mean by particles and pressure is, let's say this is container, or let's take another example. We will say we have balloon. When you have a balloon, okay, if you will blow in this balloon, after blowing in it, if you will keep blowing in it, after a while, the balloon will pump. Okay, why? What happened? Why it will pump? It will, because of the pressure of gas inside it. But what do you mean by pressure of gas? It's the air particles here, when they are moving, they are hitting the walls of the container. An example, balloon. Okay, the more air particles, the more collisions with the walls of the balloon. Okay, more collisions, it means higher pressure, and at the end what will happen? The balloon, it will explode. 9.7, the turning effect of a force. What do you mean by the turning effect of force? Okay, the force that it makes things or objects to turn. Okay, turning effect is the force that it makes objects to turn. An example, here we have this nut and spanner. Here what you are doing, you are applying force. If you will apply force on this spanner, it makes the nut to turn. So this, we call it turning effect. Again, turning effect, it's the force, the effect of force that it makes objects to turn. Opening door, it's an example of turning effect. Again, this is the hand of the door. If you want to open the door, what you will do, you will apply force on the hand. This hand, it makes this object to turn. Okay, when it will turn, you can open the door. Some other uses of turning effect, it's what? It's the scale. As you can, weighing with scale. This scale, the principle of it, it depends on the turning effect. How? As you can see here, the center of it, this point we call it pivot, and here we have the weight, and here we have the object that you want to measure it. Here what is happening, as you can see, the arrows, it shows how these two parts of the scale, it will move. 9.8. 9.8, the principle of moment. Here, the principle of moment, it depends on the turning effect. Example, here, as you can see, here we have the seesaw. The seesaw, the center of it, we have this point, we call it pivot, and here we have two forces. These two forces are acting on each other. It makes the seesaw to turn either to this direction or to this direction. Balancing up. This seesaw, it will be balanced up when the force on this side, it's equal to the force on this side with the same distances from the pivot. To find the moment of any object, you need to use this formula. Moment equal to force times distance from pivot. Again, any math question, you need firstly to write the formula. Secondly, replace the words with numbers. After that, you will write the formula. Here, the formula, you write the unit. The unit here, it's what? Unit for force, it's in Newton times, and the distance here, it will be with the meter or centimeter. Usually it's with meter. An example, okay? When this seesaw, it will move, either the movement, it will be clockwise or anti-clockwise. It depends on to which direction it will move. If it will move to this direction, that's mean this we call it clockwise. But if it will move to the opposite direction like this, now this we call it anti-clockwise. Calculating distances. Calculating distance by using this formula, the formula of moment, we can calculate the distance. For example, let's take a look on this example. Here you have seesaw and you have an object. The force of it is 25 Newton and it's 12 centimeter away from the pivot. The other object, it's what? It's 15 Newton. The force of it, it's 15 Newton. But we don't know how much is the distance. The question here, it says, find the distance here. Okay? What you will do, you will write the formula of moment, which says force times distance. So, 25 Newton times 12. This is for this part. Equal, or here equal, it means what? It's pivot. Equal to force of the other side, it's how much? 15 Newton times distance. How much is the distance? We don't know. It's x. We want to find it. Now, calculations. X equal to 20 centimeters. Calculating force. Same as previous example, but here, instead of having two forces and one distance, here we have opposite. We have two distances, but only one force. We need to find the other force. Again, the same way, you will write the formula. Moment equal to force times distance equal, which is the pivot, force times distance. Replace the words with the numbers, do the calculations. Now force equal to here, for example, 17.5 Newton. Don't forget the units. Focus on the units. A unit for measuring here the distance, it's what here? Centimeter. So also this one, it will be centimeter. If this it's with meter, also here will be meter. The unit for force, it's always Newton. Okay, as you can see here, the unit for distance here, it's not centimeter, it's what? It's meter. Now, question number 3, calculate the force F shown in this diagram, Okay, how to solve this question? Anti-clockwise equal to clockwise. Now, 75 times 40 equal to 25 times F. Do the calculations, you will find the amount of F. But which unit you will use to measure F, which represent force? Which unit? Newton. That was everything for Unit 9. I hope you got benefit from it. Things to focus in Unit 9. Again, a quick review. Density, definition of density, the amount of matter in a given volume. The formula of density, which says density equal to mass over volume. By the way, students, the lines, the words that I highlight them, these are the main words of each topic. So you need to memorize them. You need to focus a lot on them. Then a unit for measuring density, gram over cubic centimeter. Two ways to find the volume. Regular shape, you will use volume equal length times width times height. If the shape is irregular, you will use the measuring cylinder. How much it has water, then you will put an object in it. The level of water, it will increase. You will find the change. How much the level of water it changed. The change is the volume of the object. Mass, calculating mass. The unit is gram for mass. Then pressure. Pressure, the definition of a pressure, it's the amount of force exerted on an area. Pressure, it depends on the area and the force. The more the force is, the higher the pressure will be. The less or the small the area will be, the higher the pressure will be. Pressure calculations. Pressure equals to force over area. The unit we use it to measure the pressure, we said we have two units here: Newton over square centimeter, or you can use Pascal. The shortcut of it, it's PA. Calculating force using this formula: force equal to pressure times area, and the unit we use to measure the force, it's Newton. Pressure in liquids, you need to focus on that. Pressure in liquid, it increase with the depth. It means the deeper the object will go, the higher the pressure will be on it. The same thing it's with pressure in gases. Okay, in gases also, if as higher you go, the less the pressure you will have. Why? Because when you go up higher, what will happen? Less air particles will be on you. Less air particles, it means less weight and then less pressure. Turning effect force, we say it's the force that it causes objects to turn. Some uses of it: spanner, opening door, and weighing the scale or the balance. Then principle of moment. What do you mean by principle of moment? Okay, it's the turning effect on an object. Example of it, it's seesaw. How to find a moment of any object? You need to memorize this formula: moment equals to force times distance from pivot. A unit for it, the unit will be, you can get the units from the equation. Okay, if for example here, if the force, always the force will be measured with Newton. Okay, so force, the unit of it, it's Newton, and distance, the unit of it, it's either centimeter or meter. It depends on the question. So the unit of moment here will be N centimeter or N meter. It depends on the question. That was everything for Unit 9. your task, dear students, will be solving the questions, the end of unit questions. I hope everything was clear. Please, students, when you will watch the video, when you will finish watching the video, please write a comment below, so I will make sure you received the video, you saw the video, and everything it was clear for you. If you have any questions, any concerns, please don't hesitate to text me. Thank you and have a good day.